There we go.
You've done it first, so I don't need to worry now.
That's it.
Yeah.
Hi, everybody. Thank you for joining. My name is Trigger Met from Dimension Software. And we were thinking together with Ross Benton from Safety Solutions to go over a topic that sometimes is boring, but let's make it exciting, which is about alarm management and how we can think about that, starting from maybe bigger problems to really have it managed. So, Ross, could you do a small introduction about yourself?
Certainly. I'm Ross Benton, work for Safety Solutions. So we do process safety consulting. So we're helping our clients understand what hazards and risks they've got and how to manage those risks. And obviously alarm management is one of those aspects. I've come from a control systems background, so I've been doing alarm management topics for the last 15 years or so.
Fantastic. So welcome to the office.
Thank you.
And looking forward to have a small chat about alarms. So let's start first with quantifying what we talk about alarms, because alarms is a broad topic. So let's quantify that first. So when we talk about alarms, what alarms are we talking about? What is this about?
So from a process safety point of view, we talk about different layers of protection. So we have the process control, which is maintaining the process within an envelope that is the operational envelope, so making sure that production is good. And then if the process goes outside of that envelope, we're starting potentially to go into a hazardous area. So we have alarms that sit around the outside of the process control. So it's our first indication that things aren't going quite right with the process. If it goes past the alarms, we then might have an automated shutdown system, relief valves. If we get a release, we might have buttons. Those are our later protections. So the alarms are really the first line of defense against a hazard occurring.
So when we talk about these alarms, who is using them most of the time? Or are we too, let's say, focused on it's only the operators, or we should think broader about this?
Obviously, the main focus is operators, but that takes a different view depending on what type of company you are. So you might have the situation where you have an operator sitting in front of a screen and they're purely there to respond to the plant performance and what it's doing and respond to those alarms. We have other companies that they don't spend much time in the control room at all, and they get their alarms whilst they're out in the field doing work. And those alarms will come from different sources as well. So you've got the process control systems, you might have fire systems. And so they might be getting alarms from different places that they have to respond to.
Nice. So now that we understand what the alarms and the users, but there could be also users, let's say, you have the operator, then maybe you have the safety people, maybe you have also, let's say, management or the operational people wants to see what's happening. So they have different ways of looking to these alarms.
We generally split out what we call alarms and alerts, and events as well. So an event is just something's happened on the plant and the control system has recorded that, goes into the historian, and you can go back and see that state. Alerts are things that the operator themselves don't necessarily need to respond to, but it's good information. And then, as you say, we've got alarms as well, which are the things the operators are immediately responding to. But you're right as well, like maintenance. Some information might not be relevant for the operator. So if an instrument breaks, it's not urgent for the process to be responding to, but you need to get someone in to fix it. Shouldn't necessarily go straight to the operator for them to then raise a work order. You could actually have a system that sends it to the maintenance technician. Correct. And they can get into it. So there's some nuances around how the systems work and interface, and getting it all separated out is actually one of the tricks around managing alarms.
So now that we have an idea of these alarms, these events, and different users and how to use that. So when we talk to customers, we very often see it as, maybe it was good 3-4 years ago. and then little by little some problem starts to creep into the system, or maybe settings have been changed. So let's say I'm now in a position that there are too many alarms, it becomes unmanageable, or it becomes very stressful even for the operator because there are so many alarms. So you don't know anymore what is critical, what is noise, and so on and so on. So what would you advise then, or how would you approach a customer like that to say, okay, how do we tackle this now? What would we do first, and then step by step improve that?
I suppose the tempting thing for a client is to just dive straight in and start fixing problems. But that causes a problem because if you fix a problem or you think you're fixing the problem, you might be creating problems elsewhere, and you might not be doing it to any particular methodology. So the standards for alarm management, the ISA 80.2, for example, has a life cycle sort of management process for setting up how to go about managing alarms. So the first thing you need to do is put in an alarm philosophy, and that's going to make sure that anything that you do with the alarm system is done to a particular standard and is repeatable, and that everybody's doing it in the same way, and that you're not going to start getting outliers about the way things are managed.
So you have that document, which sometimes it's maybe 20 pages, and other customers maybe 60 pages. So sometimes it's a heavy document. What's really important in that document so I can understand it and then maybe operationalize it?
Lots of things are important in that document. The first thing I'd say is it should tell you how to configure your alarms properly. So one of the main things about configuring alarms is prioritizing them.
Okay.
So we put a priority on an alarm so that if you get multiple alarms coming up at one time, you know the ones that are the ones that
correct
to be focused on first. And again, if you haven't standardized that process, you get an engineer who's installing a new piece of equipment, and that piece of equipment is the most important thing in the world to them because it's their project. So their alarms that are important, that they see as the most important, they might prioritize them as the highest priority. But on the scale of the whole plant, it might be a backup system or something that's not that important. So you need to have a standard way of approaching how you configure that alarm and how you prioritize it, so that in the whole scheme of the information the operator is going to get, they're getting the relevant information at the relevant time.
Okay.
So probably a good time to talk about things that an alarm needs to be.
Okay.
It needs to be timely. So it needs to go off at the right time. The operator needs to have enough time to respond to it. It needs to have a response. So there's quite a lot of things get configured alarms that the operator can't do anything about. What's the point in having that information overloading them when they could be responding to something that actually does have a response? So making sure we get those factors in.
Give some examples of how to think about these alarms and the problems of alarms.
Yep. So once we've got the philosophy and understand what we should be doing, we talk about benchmarking. And the alarm standards have a number of metrics for measuring the performance. So you've talked about how many alarms you get in a 10-minute period, an hour, a day. So there's a metric there that suggests what is good. And then we also have things like frequent alarms, and so the alarms that come up most often, and chattering alarms. And we can then do a benchmarking exercise where we work out how good your alarm system is, and then start looking at where the areas of improvement are. And as the 80-20 rule that always gets talked about, if you start looking at your metrics and you start looking at your bad acting alarms and the ones that are causing you trouble with those metrics, for 20% of effort, you'll probably get rid of 80% of your problems.
So, for example, what is then the dormant, the ones which we can see a lot of ones? Let's say it's like your screen is full of alarms, and then the ones we don't see or could have big consequences potentially even. How do we tackle these guys?
So sorting out your metrics and reporting on that is the first stage. As I said, probably will get rid of 80% of your problems. But what you're not going to understand from working on your metrics is whether your alarm system is configured properly and whether you've actually, all the alarms that you've got have actually been designed to the standard that you've now set out in your philosophy. So the only real way is to actually go through every alarming point in a process we call rationalization. And you start looking at all those aspects of design. Does the alarm have a purpose? Does it have a response that the operator can do? Is it in a timely manner? So how quick is that response? We use that information. Well, how bad is the consequence as well? And we use that information to generate the priority of the alarm. So it's usually a consequence versus time correlation. And we look at all the other configuration things like putting on delays and hysteresis to stop them if you get spikes, alarming and things like that. So
that's the most. So we have our alarms philosophy. We have, let's say, a whole process in place, understanding, monitoring. You rationalize them. So you come to a point that you should come to an acceptable rate of alarms. Okay. So what do we do now? So we have the alarms which are in a certain, let's say, shape. We start to improve. What's next? What we can do? And I understand this is, of course, the continuous improvement we have to do. We cannot just say we have done all the steps which the ISO 18.2 of another one, there are a couple of them, are proposing. It's a continuous process we have to do. We cannot just stop because we have done it, because otherwise it will go down after some time and we come in the same condition as we were maybe 2 years or 3 years ago.
Yep. So we have the initial state of our process, and hopefully we're improving it by doing this bad actor analysis. And bad actor may not be enough either. You might have to get into more advanced alarming techniques, which will do state-based alarming, so that you're removing alarms if different plant conditions are in place. So that there's a lot more to it than just trying to meet the KPIs and that side of things. But once you've got to a steady state, nothing ever stays steady. Someone's always going to be making changes to the plant, new equipment being introduced. So if you've got new equipment, you really need to make sure that alarm management is embedded into your MOC process. I see it quite a lot with companies where they get contractors in to come and install this piece of equipment, and they don't give their alarm philosophy to the contractor or make it an important part of the process. And they come in, and as I said, with the engineer that decides they're makes their own mind up about alarms and does it to their own standards, it's not aligned to your standard anymore.
Correct.
So MOC is a big creep.
MOC stands for?
Management of change.
Okay.
Yep. So you've got that. You've got potentially operators requesting changes to alarms that are not authorized. There's lots of other things that can cause your alarm system to start drifting away from the standard that you've set.
Okay, so that brings me to the following, because we make changes in the system, authorized or non-authorized, because there's a change that we have to apply. How are we sure that maybe the initial standards are still followed? How can we check that? Because I think there is a master alarm database where, for me, that's your truth. That's where your design is in. There's the agreed alarm levels, and aligned, of course, with the philosophy. There you have your master alarm database. So maybe it's a good moment to introduce what does that do in the total, let's say, philosophy of alarms.
I suppose to use a good industry buzzword at the moment, we talk about digital twins.
Okay.
And that means a lot of things in different situations. But for alarms, the master alarm database is effectively the digital twin of the alarm system. And we use the master alarm database as the place where we record all the details that we've been talking about. So the response times and the consequences and the priority of the alarms. And that becomes the authorized version of what we've got. So anything new that's coming in should go through a rationalization process and be put into the master alarm database, so that when that alarm gets applied in the plant, we know that we've got it to a certain standard and it's been done. But what we can use that master alarm database for as well is auditing. So it should be locked down. It should be, once you've been through the review process, everyone's agreed the information that should be in there, it should be then locked so that it doesn't get changed other than through an authorized process. And then when you compare it to what's actually configured on the plant, you can see any deviations from that database. So you can see any new alarms that have been added, set points that might have been changed without full authorization or management of change process.
Do you see that with a lot of companies? Do they have that, which is really well maintained? Or is it still in a paper-based or Excel-based or?
There's a mix out there. Yeah,
Okay.
there's software systems that obviously Dimension have got their system that you can have it in a one place where you've got your alarm monitoring and your database, and they can actually talk to each other. The first system I developed was an Access database, and that worked perfectly well, but it has its limitations. And for rationalization exercises, quite a lot of companies use Excel as well, because the ability, if you've got similar alarms, copying and pasting data is all there, and it can be a little bit simpler to use it. But Excel and those databases don't have the authorization and the management behind it. So having a software system that helps you do that management can be quite useful.
Because if you talk about Excel and so on, I mean, you can do a lot of changes. You don't have, like, say, a workflow behind it or
exactly,
or a standard behind who is really controlling what you do.
Yeah.
And also, let's say, put audit in your system to say who has changed what, when they have changed it, and so on. So where Excel is still free world, you can do whatever you want with it, and maybe there is some rules in it, but it's not going to be the same. So for, let's say, heavy processes, be careful, I would say then.
Yeah.
Okay, gotcha. So this alarm database, what do you keep in it? Is that everything that you have in there, or is the alarm, the levels, the assets,
That's a big question.
To help you out, you have the standards, right? The standards of an alarm, but do you see also an evolution, for example, and because we talked about safety, when we talked in the beginning of what is an alarm, there is also the barriers that you want to go. Is it also start to see that as a link from alarms, but then also safety elements that start to be linked to the alarms or to the assets? Do you see that also?
So if you've got a digital database, you have the ability to link all of these things up. So the ultimate solution is you have your hazard ID process, your hazard operability study minutes recorded, which has so that process goes through, identifies what hazards might be on the plant, what will cause those hazards, and then will identify all the controls that you've got in place. And the alarm is one of those controls.
Okay.
So if you can have a digital system that then it gets identified as an alarm, so then links into the alarm in the master alarm database, sure, you're broadening the scope of the information that you can generate around control management. And we talk about bow ties, it's a whole nother topic, but bow ties are a way of visually taking that information from the HAZOP and putting it into a way that is scenario based, and you can look at all the different causes of a scenario and the controls that are being implemented against it, and you can have a live bow tie if you've got live data coming in from that links to your master alarm database, which says this should be doing this, is it doing it, If it's not, it's compromising the safety of our plant because it's related to this particular hazardous scenario. So with the potential that we've got with data lakes and gathering all the information, there's a huge benefit that can be gotten out of using a connected system.
Nice. So we went from, let's say we have problems with our alarms. We have now rationalized them. We monitor them. We have our alarm database, master database, where you put everything in. So what are now the benefits of having, let's say, an operation where your alarm limits, your alarm rates are acceptable? You understand your alarms. You understand the consequences of if something gives an alarm. You understand what you have to do and the consequences. So what do you see there now as the next maturity of a company? What can they do next now? Now that everything starts to be under control, because one thing is to apply a standard. Great, done. But that's just the beginning for me, because now you have the next layer of opportunity. Now that your, let's say, your operations under, let's say it's under control, you understand what's happening. What do you see as the next opportunity?
Probably a good time to talk about the EMUA 191 alarm management standard. So I see this standard, it's more of a guideline document of how to help you manage your alarms rather than setting the things that have to be done. And in one of the chapters in that, it talks about different levels of maturity in alarm management, and the levels go from reactive to unstable to stable and then robust. And reactive is a completely unmanaged system. So the operator is purely responding to alarms and not doing anything else with their day. They get too many alarms to respond to, and even the alarm system starts getting to a point where it's not actually helping at all. So the only help that it is when the alarms start flooding the screen. The operator knows he needs to start looking around his screens to try and work out where the problem is. As you start dealing with some of these issues around getting too many alarms and frequent alarms, chattering alarms, you start getting into a situation where you're going through that unstable phase where you might not be constantly dealing with alarms, but they're up too much to a point where you're actually only responding to alarms in the stable condition where something has genuinely gone wrong with your system, and it's not just a normal everyday situation. To get into the sort of robust area, it's almost like you're getting rid of the alarms so much that the operator is fully just viewing trends, and optimizing the plant. So if you get on top of your alarm system properly, and it is providing the right information that the operator can quickly identify the problems, they can spend the time optimizing production and actually making you more money.
That's because I wanted to exactly come to that point where we are used to hectic is good. No, it's when the operator is fully concentrated on the plant and understanding the trends, and the alarm is not there to, we try to avoid it. That should be the philosophy, is try to avoid it. Because once we get to that stage, we can also start thinking about, if there is then an alarm, this is a piece of information which should be used all over the place to say, how can we avoid that for the future? And maybe that means that we have to understand what the maintenance people have to do, what the operational people, safety people, so that we really start not thinking about alarms as a nuisance, but alarms as an opportunity to do it better next time and try to avoid and create a different mindset of, let's say, do the continuous improvement in your plant. So I wanted to really think about, because And in our case, we have maintenance, we have logbooks, we have all these things. But if you also think about that your alarms becomes a piece of that information to do better tomorrow, it's so critical. So do you have examples of that?
With one client that we had, it's an example of setting the alarm philosophy and how you're going to operate alarms. We went in and did an audit against good alarm practice to see how they were actually running their alarms. And the usual thing is you have an alarm list that all the alarms come through to that list, and they're prioritized, and everything that's relevant comes up on that. And their alarm list had got so overloaded that they didn't actually use that list anymore, and they decided that hard coding their alarms into their graphics was a better way of doing it. So they went through and picked the most important alarms and had them on a graphics screen. So if an alarm went off, they got an alert on the screen, but they went and clicked to that, and it came up with a page of effectively rationalized alarms. But they'd sidestepped the system that the vendor had provided to manage alarms and to do it in an appropriate way where they could acknowledge and do it, because it wasn't working. And instead of spending the time getting their philosophy and their process right on design, they'd done something different. So bringing that all back and actually going through a rationalization process, installing that, getting their alarm list operating properly, they could then actually have a system that was manageable in their alarm list, and they could operate from that.
No, nice. No, because we talked about some examples. So
yeah, I was just trying to think of them as that was one of the examples we talked about.
Yeah, that's it. So no, it's important to see that there is a life after applying your rationalization and so on. It's really thinking about how you can first of all keep up, because a lot of cases it's I have a customer where every 3 years they call in, let's say, multiple people to do the rationalization, and then 6 months later they leave, and then 3 years later they do it again. And it's that ongoing. So the question is, can we not improve that? Can we not do that better to avoid that? Because you're at a good state when they left. They did the rationalization a good way, but it's not embedded in the organization. It's just a system people did to the rationalization, and then we continue, and the old way creeped in again.
Yeah.
So we didn't have that change management, the mindset of how can we avoid that.
Yes. Yeah. So if you're installing new equipment, changing the plant, and you're not having it embedded into that process, you're going to have to call people back in to sort out your problems the next time.
Yeah.
So, and that's really is actually getting the buy-in from everybody to start with is one of the biggest headaches of the process. So you've got to get management buy-in for funding it and giving people the time to do it and implement it. Operators have got to see the value in it, so you've actually got to show them the benefit that it's going to be. The engineers who are going to actually go and make the changes have got to understand what their role in it as well. So getting that early on and making sure it's continued even after the project of improving your alarms is finished, it's got to be operationalized after that.
Yeah. So I think that's a good way to end, because we started with systems and technology and standards, right? But alarm management, as many other systems, it's not only about the system or the standards. It's also about the people and how we can then embed that change in the organization. And alarm management is not just a system. It's really a culture of how you handle that. It's like safety is a culture. Alarm management is a culture. So it's really thinking about that. It's about the people who work with it daily, how they can embed it and doing it better. And if they have less alarms, your plant is running better. Definitely. Much more efficient, much easier. People will be happier also to come to work because the plant is operating. You must have the right process, and not the process of acknowledging alarm, but also if it's a change in your plant, Then you have your processes that should put it in the alarm master database or whatever it is, or adapt your philosophy, but then also adapt all the other things. And last but not least is also your system. So have systems in place who help you maybe with certain workflows, with certain change management systems. So I think it's a good end to say that, yes, we started with what's an alarms, but I think it's thinking about your organization and embed your alarm management in your organization. I think that would be the best outcome for everybody.
Yep, definitely, I'd agree. And just diving in without any structure, without all that buy-in, and without the processes, you might make a difference initially, but it's not going to stay long term.
No, fantastic, Ross. Thank you very much. Thank you for passing by, and looking forward for the next one.
Indeed.
Thank you.